All right, D8, adding and subtracting rational expressions. There's a list of some steps right there you can follow. Long story short, you need a common denominator. Once you have that common denominator, we can add or subtract your numerators, leaving your denominator there. And then simplify at the end, see if anything factors and cancels. So that's pretty much the gist of it. So let's go ahead and go through these and see what happens. All right, number one right here. Our denominators are 3x and 2y. When in doubt, so 3x, 2y. When in doubt, you can always multiply them, and that will give you your lowest common denominator. Not your lowest, but it'll give you a common denominator. In this case, it is the lowest common denominator. That's not always going to work out. All right, so 6xy. So this right fraction, I need to multiply it by 3x to get 6xy. Whatever you do on the bottom, do on the top. For the other fraction, let's multiply by 2y. Whatever you do on bottom, do on the top. So my denominator for both of these fractions will be 6xy. My numerators, so let's multiply these out. Negative 14xy squared. Let's multiply these out. What do we got? 12xy squared. All right. Once you have a common denominator, you can add or subtract your numerators, leaving your denominators alone. All right. This one's going to work out real nicely. Those two terms in your numerator are like terms. Same letters, same exponents, so they are like terms. You can just combine them. So negative 14 plus 12 is going to be negative 2xy squared. Let's reduce, cancel, factor, all that good stuff to simplify this expression. So these x's will cancel. This y will cancel with one of those y's. And 2 6's will reduce to 1/3. So we are left with negative 1y over 3, or negative y over 3. There is number one, and that's where that one ends. Does not simplify any further. So number one, if you notice what we did, let me just kind of clear out. Oh, let me leave that on. You can always just multiply your denominators. Multiply, kind of cross multiply in this fashion. Like there's a 2y. And that will give you the numerator of the left one. Cross multiply on the other side. That's what we did here. And that will give you this one as well. It always works. It just does not always lead to the lowest common denominator. So you would have to make sure you reduce, factor, cancel at the end. So it will always work. Just multiply, 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 go from there. But again, it does not always lead to the lowest common denominator. All right, having said that, let's go to number two. So this one, see, if we were to multiply these, we would get what? 15 a cubed b to the fifth, and then you would multiply there. However, it would not lead to the lowest common denominator. It'll work, but at the end, it'll be a few extra steps. So I'm not going to go that route. Again, you can if you wish, but it's not necessary. 3 and 5, so 15 will be the lowest common multiple for those. So we'll do times 3 and 3 on the left fraction, times 5 and 5 on the right fraction. What else? What else? What else? So the fraction on the right has a squared, so we need that. Let's introduce an a on the left side. So we'll get a squared when we put those two together, matching that term. My b's, I have b cubed and b squared, so I need another b. So now, when you multiply those two, it'll match the b cubed. So, let's leave that there. Clear this a little bit. All right, so let's see what's going to occur. Up top, this guy is 6ax. On the bottom, this is, let's see, 15 a squared b cubed. Over here, that numerator is 20 by. I'm just putting in alphabetical order, b before y. It's not necessary, but commonly done. This denominator better match the other one. 3 times 5, a squared, b squared times b. Oh, and as you can see, they do match up. So that's your lowest common denominator. All right. So now we can go ahead and just take care of our numerators. Let's clear this. We don't have any confusion. So up top, I have 6ax plus 20by. Common denominator, just bring it down. Looks like this. So anything we can factor out to potentially cancel with the 15 a squared or b. I don't see it, but let's go ahead and double check. So our variables are good. We cannot factor out an a out of the numerator, a b, an x, or y. If we were to factor out anything, what would it be? 2? And we would have 3ax, 10by, but 2 and 15 do not reduce. So that does not do us any favors. So we're good, unless I made any errors. It appears this is our final answer. Now, had we gone the other route that I mentioned, again, it would have worked just fine. In fact, I'll go ahead and do that here as well. So we would have to reduce a bit more at the end. So if I multiply these two together, we would have got 15a cubed b to the 5th. I multiply these two together, what do we have? 6 a squared b squared x plus in the middle. And if I multiply these two together, let's extend this. What do we have? 20. Then we have a b cubed y. All right, so we would have to simplify at this point. 6, 20, and 15, no common factors. Up top, let's see, what do we got up top? We can factor out an a, so we'll put an a out. We can factor out b squared, so we'll pull that out. So what will remain is 6ax 20, we're pulling an A out, so that's gone, BY, okay. Running out of space. On the bottom, so I hear that 15, that's gonna stay. You can pull an A out, you can pull a B squared out. So we'll be left with A squared, B cubed, and then these would cancel here. A times A squared is A cubed, B squared times B cubed is B to the fifth. So if you went this route, you get the exact same answer. Oh no, let's pause this 1 second. All right, got that fixed. So these match up. So either route works, just kind of depends which way you want to do it. Depending on the problem, sometimes one method works faster or easier than the other. So that's number 2. Alrighty, number 3. So for this one, there's not much we can do except multiply our denominators. So our lowest common denominator in this case will be the product of x minus 1, x plus 1. Those are conjugates. It'll result in difference of squares. So that's our lowest common denominator. So this one we'll multiply by x minus 1, top and bottom. The other one we will multiply by x plus 1, top and bottom. Whatever you do on bottom, do on top. And that will give us what we need. So our denominator will be x squared minus 1. And we are essentially using that process where we multiply our denominators, we'll multiply these, multiply those, and it will check out. All right, so be careful with your minus. There's a big minus in the middle. So we're subtracting the entire product of x minus 3 times x minus 1. What's that going to be? X squared plus 3 on the back end, minus 3x minus 1x, so minus 4x. So that was that product. Blue. Let's go ahead and multiply these. Box method, FOIL, distribute, whatever you got to do, guys. X squared, 1x plus 2x is 3x, 1 plus 2. So it looks like that. So parentheses, I highly recommend them right here for the second product, especially when you're subtracting that entire product, because that minus is going to apply to every term before we combine like terms in our numerator. So it's going to be minus x squared plus 4x, because minus minus, minus 3. Denominator is still there. So let's go ahead and combine like terms. X squared minus x squared. So that's there. 3x plus 4x, 7x. Took care of that. 2 minus 3, so minus 1. All right, so 2 minus 3, so let's go ahead, minus 1. All right, there's your final answer. You can leave it that way. Some textbooks, teachers, professors prefer a denominator factored out, but they are exactly the same, so either one is good enough for me. Nothing else cancels. So that one's number 3.